I'm Ed Niedermeyer. I'm the communications director here at Partners for Automated Vehicle Education, and I'm thrilled to welcome our newest member, Ouster LiDAR, and I am joined today by Ouster's founder and CEO, Angus Pacala. Angus, welcome.
Thanks, Ed. I'm glad to be part of PAVE.
We are glad to have you as well. For those who don't know, maybe could you just introduce yourself and Ouster?
Sure. So Ouster is a leading provider of digital LiDAR sensors. So LiDAR sensing is a critical sensing technology for the autonomy stack. And Ouster is bringing a highly integrated digital technology to an industry that's been dominated by kind of an analog technology set for its entire history. And this is a natural progression that lots of products take from analog to digital, whether it's CPUs and GPUs or telecom infrastructure or cameras. And so Ouster is doing this analog to digital conversion with LiDAR for the very first time. And there's benefits and affordability and performance that come with that switch. And also a broadening of the TAM. You know, one of the things that we're really focused on is this idea that autonomy is a global trend that spans industries. You know, automotive is one application for autonomy technology, but it's really broadly applicable. And one of the most exciting things is how it can bring safety critical, life-saving, and efficiency improving technology to industrial, smart infrastructure, robotics, and automotive, which is a core part of our strategy. So that's Ouster. And my background, I'm a mechanical engineer by training. I still love to get involved in technology and talk about the future of technology trends. So, you know, it's a pleasure to kind of be here and talk about that stuff with you today.
Yeah, I mean, the diversity of autonomous vehicle applications and just the diversity of the technology and all the different forms it can take is definitely something that even within sort of the automotive and mobility space, we really try and do a lot of education around, because it's so easy for people to think of self-driving cars and they just think, well, you know, it's like a car today, and you know, but there's really so many, again, even just within automotive, before you get into all the other categories you talked, there's just so much diversity, and that's definitely been a big educational point for us. So we're definitely aligned on that. But sort of more broadly, you know, what is it that that brought you to PAVE? Why are you joining the educational coalition here?
Yeah, well, I think that at its core, autonomy is a safety critical technology, right? The goal here is to get the technology to a level of reliability where consumers are comfortable falling asleep in their cars, turning over control, of really putting their life in the hands of a complex piece of mechanics and sensors and software. And anytime you're working with safety critical technology like that, I think transparency of how it works should be a goal. Right? We want people to be comfortable through transparency and not obfuscate what's going on. And so LiDAR is really the critical core input to this entire system. It's the eyes of the vast majority of autonomous systems. And so I think it's great that people understand how the eyes of those systems work, if they want to, right? And that leads to better oversight, and it leads to making sure that it holds companies accountable, whether it's LiDAR companies or other companies further up the stack. It holds us all accountable to making sure we're taking the right care and actually bringing this kind of technology to market. So I think that's what I'm excited about. Yeah, it's just educating the public. Yeah.
That's a fascinating perspective, because I think you're absolutely right that safety, being a safety critical technology, really means that you kind of have to approach this differently than, you know, sort of the established ways of approaching lots of other technologies. And I love, and education, it makes so much sense that it has to be part of that, because it's not just safety critical, but it's I mean, you're literally trusting your life to technology, yeah. Right? Beyond sort of the need for education, which I think you explained really well, like what else, sort of how else does being in a safety critical technology space sort of change how you approach your work and the technology and your interface with the public, maybe that you wouldn't maybe necessarily do with something that wasn't immediately safety critical?
Yeah, I think that there's a different towing of the line on how we communicate the excitement around this technology, because we're based in Silicon Valley, and there's a common trope, which is move fast and break things, right? That's the startup mentality. And you actually can't do that with safety critical technology. You want to move fast, but only at a cadence that you can support releasing the technology responsibly. And so divorcing ourselves from some of what Silicon Valley has built, an ethos around, like move fast and break things, but also kind of communicating the immense opportunity and the optimism around the technology is important. Like, we want to talk about all the great applications for the technology and be optimistic, that's good. But we also have to be way more kind of responsible in the rollout than like anyone developing an app, like a consumer application for a consumer's entertainment. And I think that's a fun challenge, actually. It's just like a communications challenge that's very unique to this industry.
Yeah, absolutely. We've definitely seen what happens when there's too much hype, right? But you're right. I mean, this is such an exciting space to be a part of right now, because we're looking at a century of change that it's going to unlock, and I think education really is a great way to kind of find that balance, right? With sharing that excitement, getting people interested in it, but doing it in a way that really feeds people's desire to actually really learn, and not just anticipate some sci-fi vision, right?
Yeah, and I also I think that the scope of this of the adoption of autonomy technology into myriad use cases is something that people haven't probably fully wrapped their head around. So giving concrete examples, like, what does it actually mean to have LiDAR sensors on traffic poles? Like, what is it going to do there versus having a LiDAR sensor on a car? And I like, it's giving people a vision for that. A LiDAR sensor on a traffic pole that is making a crosswalk more intelligent could keep that light on longer for an elderly person that takes longer to walk across the intersection. That kind of thing is a great benefit for a certain set of society. There's simple examples like that that actually put this in perspective. I'm like, oh, okay, I get it now. You need you need sensing to have things intelligently interpret their environment and do something that's better than just an unintelligent system.
Yeah, absolutely.
So yeah.
Well, I was just going to say, I mean, the proliferation as more and more LiDAR gets out there. I mean, we're going to have a sort of be able to represent like every aspect of our world in like really much more precise ways, right? I mean, especially like if we get to the point where every vehicle on the road potentially has this kind of stuff. I mean, the amount of data is going to be really amazing, isn't it?
Yeah, well, certainly, LiDAR is giving context to computer systems. It's giving computer systems information and context about the environment that surrounds them in kind of unprecedented detail, which is really important for the computers, the algorithms to actually do something reliable and intelligent. But one of the things that is a little strange here is that there's no actual visibility into what the computers are doing. And I'll give you an analogy. So with consumer technology, there's been a lot of development in machine learning, and consumers kind of get to know with entertainment applications what the machine learning does. It's like it puts ears on your head when you're like having a video call or something. It's doing face detection and that kind of thing. With that same technology same types of technology is running in the background on these autonomous machines, but no consumers actually really ever get to see the output. And so that's a bit of a challenge, but it's pretty staggering, the quantities of data and the capability of these systems as they run in the background.
Yeah, and I think people don't necessarily always think about how different it is to have machine learning, again, making life and death decisions versus finding all the pictures of your mom in your photo collection, right? Or something like that. I mean, this is autonomous vehicles really sort of asks the machine learning part of the technology to do things that it hasn't really done a lot in a lot of other applications. And sort of your point seems to be that maximizing the amount of data that those systems have to work with is really going to be sort of fundamental to making sure that they can perform at that safety critical level. Is that right?
Yeah, I think that when we talk about rolling this technology out safely, core to it is choosing the right sensor suite. That's why LiDAR sensors are used on the vast majority, almost all self-driving cars and autonomous machines. It's because LiDAR gives the best data, the most reliable data in a variety of different weather conditions and environmental conditions. So you want to have the right sensors, the right inputs to the system. You want to have redundancy as a core concept in any safety critical system. And then you want to have a validation verification process that is incredibly rigorous. And that's where the move fast, break things mentality just absolutely cannot apply. And so the combination of those three, I think, is what's necessary to get this technology out safely. And we've seen how this can go wrong with other autonomous technology. And I think that the 737 MAX situation is one where there was a breakdown on multiple levels. One was in the core concept of redundancy, where they only had one angle of attack sensor on the 737 MAX. And if that sensor goes, malfunctions, then the computer doesn't know what to do. And also on the verification process. So the release process for MCAS system in the 737 MAX was broken. There wasn't the right oversight. And so, there needs to be checks and balances, but those checks and balances need to all be functioning correctly in order to release the technology safely.
Yeah, absolutely. And LiDAR, it's one of the pieces of this technology that actually maybe people maybe not understand better, but are more aware of, right? And there's a whole bunch of reasons for it. I mean, first of all, this is really sort of one of the first, applications where this, well, so correct me if I'm wrong here, but LiDAR was, sort of the modern versions of it came out of, were first sort of applied in the DARPA challenges. And so it's sort of been really tied with autonomous vehicles, and it's not necessarily a technology that's been used a lot of other places. So people are aware of it, but maybe they don't always really understand it. So I'm curious sort of what, how do you see like the way that the public kind of sees LiDAR? What are some of the challenges that you're hoping to overcome with education?
So you're right. It's because LiDAR started out as these very visible big buckets spinning on tops of vehicles, it became almost synonymous with what an autonomous vehicle is. It's like an autonomous vehicle is a vehicle that has a big spinning LiDAR bucket on it. And that's a really kind of interesting dynamic. Like not all technology advances that way, where it's the most visible thing on a system of new technology. And the trend is going to go, it's kind of going the opposite direction. So when this technology gets rolled out, when LiDAR gets rolled out en masse across verticals, it will recede into the background. You will be less and less aware that there are LiDAR sensors on a car or on a traffic pole or on an industrial robot, in the same way that consumers aren't fully aware of like the fact that there are 8 cameras in an autopilot system. I challenge a normal person to find all 8 of those cameras in the system. They're incredibly well hidden. And so, I think that actually one of the misconceptions is that LiDAR is going to be this incredibly visible thing across autonomy, that people are going to see LiDAR sensors everywhere in the world as it propagates. It's the opposite. There's going to be this blanketing of the industrialized economy with LiDAR sensors. They're going to be keeping you safe, and you're not going to be fully aware that they're all there, that they're doing that job, which is not a bad place to end up. But it's probably not what people are expecting. I think people are expecting autonomous cars to continue to look like these sensor-laden vehicles for a very long time. In terms of education, I think there's a lot of things you could just point to, but I get asked questions all the time about, well, can LiDAR see through walls? Can LiDAR detect who I am as a human? The answer to both is no. A LiDAR can't do facial recognition like a camera. It cannot see through walls. Some of those, I've been asked, can a dog see LiDAR? Can an animal see LiDAR and a human can't? So there are general concerns about like maybe the side effects of having lots of LiDAR sensors in the world that are good questions to ask. I mean, this goes back to the transparency questions. Like we want people to be comfortable and understand how it works so that they're not worried about, like their pets being annoyed by LiDAR sensors. So.
Yeah. Yeah, no, I think a lot of times our goal at PAVE is just to help people ask the right questions, right? And that can be hard enough, let alone giving answers. We oftentimes really rely on members like you to actually explain this technology, because there's no way that someone like I or the rest of PAVE staff could really be fully expert in all of these things. So what would you say is the most important, if you could only teach people one thing about LiDAR? And obviously we'll be working together for some time to come to make sure we get a bunch of lessons out there. But at this moment, sort of, if you could only teach sort of one lesson about LiDAR, what would that be?
I think that, well, one of the major debates that is public that you hear about is cameras versus LiDAR. Elon Musk has famously gone against the concept of putting LiDAR in cars ever, let alone now. And I think that it's important for people to understand this concept of redundancy. Safety through redundancy is really, really key to being able to fall asleep in your car and hand over your life literally to a machine. And again, 737 MAX, it didn't have redundant sensors. It's very challenging when you don't have redundancy. Let's say you only have a car with cameras. If those cameras turn off or glitch for any reason, then the car is literally blind. And that's not a great place to be. So this is very much, any debate about what technology is correct is the wrong debate. It's not an either or. This is it's complementary. So we want to have cameras and radar and LiDAR and GPS and inertial measurement units and wheel encoders. We want lots of different inputs for sensing the environment around these vehicles and making them redundant and safe. So I hope that people get past this idea that it should be either or any kind of dogmatic debate around either or. I want to be in a car that has LiDAR and cameras and radar in it.
Right,
Yeah.
exactly. Because and beyond the redundancy issues, there's also an issue with just the diversity, right? Like different sensors perceive things in different ways, right? And so and cars, one of the most like fundamental aspects of cars that people I think oftentimes overlook, but any kind of vehicle, is that it has to work in every condition. And as an engineer, that there's a big difference between making something work and making something work in any and all conditions that you're likely to see, right? And so maybe could you just sort of explain sort of with having diverse sensor modalities, what does that do beyond the redundancy?
Yeah, sure, and that's a good point. So it's redundancy in most cases, but in environmental conditions that some a camera and a LiDAR in fog don't work as well as a radar. At nighttime, a camera doesn't work as well as LiDAR, and so that's absolutely true. In changing environmental conditions, you might want to rely on one sensor modality more than another. Another misconception that I think people have, and this brings up a good point, is I think people expect that autonomy will be a binary shift. You'll wake up one day and there will be autonomous cars everywhere in the world, and no one will be driving vehicles, and it's going to put a bunch of people out of work. And it couldn't be further from the opposite. The fact that there are all these edge cases around environmental, fog and rain and snow and unique environments that are more or less challenging for an autonomous vehicle to navigate means that the main source of redundancy that we will have for a very long time is an additional driver, a human driver in vehicles. And autonomy technology can be about complementing a human driver, just in the same way that LiDAR can complement cameras and be redundancy that way. Humans can complement autonomy. Autonomy could complement humans and make a human driver more safe and more efficient, improve the quality of their life through an easier working environment, and reduce workplace accidents. And that's where we're going to exist for a very long time, I think.
Absolutely. And in fact, I mean, the first time someone gets into a vehicle with LiDAR in it, it may not be fully autonomous. And as you sort of mentioned earlier, you might not even really know, because you might not be able to see it at all. Why is LiDAR kind of becoming more a part of the conversation around driver assistance systems they're not fully autonomous? You still need a human behind the wheel, but you still want that perception that LiDAR gives you. Why is that?
Yeah, I mean, it's the same reason why it can be beneficial to have a someone in the in the passenger seat, watching what you're doing when you're driving. The concept of a backseat driver, I don't know. It's humans are pretty good at driving most of the time, but there's that 1% of the time where their concentration shifts. And so it's great to have an assistance feature that warns a human when they break their concentration. And so that concept applies for cars, but it applies for all kinds of human operated equipment. We have some customers that are deploying it's like a driver assistance system, but for huge gantry cranes at port yards. And they're moving around containers in these massive port yards, and it has this collision avoidance system powered by LiDAR. And it's not that it's not fully autonomous, it's just an assistance, but it is preventing multi-million-dollar crashes from occurring in a port, and hopefully saving human life or preventing injury as well. And so that can be applied to a waste management driver, a big 18-wheeler, big rig, a train, a boat, all kinds of construction equipment. So the concept of assistance is really powerful, and the assistance technology is identical to autonomy technology. It's just that you're not turning over full control of the vehicle to that system, but it's still doing all of the interpretation and analysis of the environment, and to try to predict when accidents might occur and actually warn the operator.
Yeah, absolutely. One of the statistics that really always sticks in my brain is that 75% of pedestrian deaths happen in low light, happen after sundown. And it seems to be one of the real sort of strong arguments is that with LiDAR, we could potentially sort of make more of take a bite out of that, at least with some assistance systems that might not be an option, because as you mentioned, the nighttime performance of a LiDAR versus a camera is such an improvement, right?
That's exactly right. Right, like there is so much preventable death and injury that occurs because that could be prevented by better sensor suites, by better having LiDAR, having more advanced cameras, having more advanced radar. And it's the responsibility of companies like Ouster to make the technology performant and affordable enough. And at this point, it's really about affordability, and to actually get the technology in as many hands as possible, right? At the end of the day, it only matters if we can commercialize the technology and make it affordable enough that everybody can use it, that we can significantly improve or reduce workplace accidents, roadway accidents, pedestrian accidents.
Absolutely, and it's so exciting to know that we'll be able to have a front row seat to watching all this happen, and all the potential improvements that lie before us. And I'm extremely glad that Ouster has joined with PAVE so that we can continue our educational efforts with your help. This has been a fascinating conversation, and to me, just really shows what we can do together going forward. So thank you so much for making the time to speak with me today.
Thanks, Ed. It's great to be a part of PAVE, and looking forward to the next conversation.
Absolutely.